Welcome to the Econometrics class, MN M038, Econometrics. My name is Hani Abdulatif, for those who see me for the first time. I'm a lecturer in the economics department, and I'll be lecturing this in this module this semester. For the econometrics, or what I'm planning to do today, I'm going to give you some kind of overview of this module, what we are planning to do, and how we are going to run the sessions, what is expected from you, etc. But I always think when I teach econometrics, I always think that it's very important to ask ourselves, why do we really do econometrics? Is it just for the sake of having fancy equations and fancy models and some estimations, things to talk about, to make our work as economists or researchers looks a bit complicated or some kind of showing off with what we know? It's not like that. So you always need to think about the idea of what you are doing, and sometimes, as you will see in this module with econometrics, you will see that there's a space or there's room for you, for your own judgment, to which method you use, what fits your data, what is more appropriate to the research question, etc. So there will be some sort of personal judgment at some point, okay? And in many instances, you'll see this very clearly. If I would like to summarize the idea of the whole module, or my approach to teach econometrics in one sentence, is going to be, this sentence would be, is always why we do econometrics. So the idea is, maybe in your undergrad, some of you have done econometrics, some may have not done econometrics before. Don't worry, you'll know all about it this semester. But in general, even those who did econometrics in their undergrad, so they usually do the technical stuff. They think of econometrics as, okay, we press some buttons, we get some results, and we interpret the results. Hey, we pass. That's what we do. But in this module, I will always ask you to be critical about what you learn. Think about why you do it. You will be asked to read research papers, comment on those research papers. This is your exam, by the way, and that's exactly what you see in the exam. So what we will be doing in the class here, that's what we'll see in the exam. And that's the philosophy of the whole module, okay? Is to be very critical about methods, different techniques. You need to be aware, not just why using a certain method. You need to be also aware of the limitations of these methods, okay? And that's what you need to demonstrate, okay? As part of your assessment, that's what is expected from you. Not just to be able to do it, you need to be able to do it and say and explain why you choose that method and what are the limitations, because there's nothing called perfect model. Always there will be always limitations, there'll be always problems, there'll be always issues. We live in the real world, is different from textbook examples, okay? And that's what you will be doing in your research project. We'll come back later to talk about the assessment. So that's why I believe that one of the first or the most important step, or the main point that I want to highlight today, is the philosophy of this, what we're trying to do here, what we're trying to achieve, and what we want to achieve by the end of this course. That's why I always start with economic research and the idea of economic research and why we do economic research. Before I jump into that, here you can find me everywhere or anywhere online. So Facebook, Hanomics, my website, my webpage, Hanomics on YouTube, Hanomics on Twitter. So just search for Hanomics, you'll find me. Okay, why that? Because I'm recording the lecture now, and hopefully sometimes there are technical issues, but hopefully I'll record all lectures and they will be on YouTube. In the past, I even broadcast some lectures live, but I'm not planning to do this semester. So I'm not going to broadcast lecture live. Will be only recorded, and hopefully I'll upload them on YouTube. This hashtag, I used it in last year with this class to share with you research that applies methods we learn about in this lecture, in this semester. So it's very, very important as well to follow this hashtag on Twitter. And whenever I post something, I will let you know anyway. I'll email you, but you feel free to follow me wherever you want. Facebook, YouTube, Twitter, whatever. There will be a course page on my website as well, but everything will be posted on Blackboard, okay? But also, I'll post more stuff on my website. Anyway, so let's now come back to the point. Why do we do economic research? Why do we need to do research? Why we keen? As I said, it's not just because you want to show fancy stuff and nice stuff and publish, etc. There is a question we want to answer. Okay, so in your coursework, in your dissertation, maybe when you go to work after this, if you want to write a report, if you want to do any piece of research, whatever the context is, you will be always looking for answers, and that's what we do. Okay, so we're trying to find answers and to convince people that this is a good answer. We can't just tell them the answer. We need to explain how did we come to that answer. Okay, so you need to describe, not just telling, you need to describe how did you come to this conclusion. Okay, so to write a research paper, you can write a theoretical research paper where you just have you study the incentives or constraints of that face your economic agents. When I talk about agents, it could be a firm, it could be individuals, household, countries, etc. So your subject. And based on that, you can expect their behavior in certain situation. So in economics, it's the most basic thing we do. Or like when you start economics, you start talking about when prices increases, quantity demand decrease. So kind of like theoretically or economic theory tell us that, but then we need to test that. So we need to use data. So we write empirical work. So theoretical work based on some assumptions about agents, restrictions or incentives they have, and then you predict some outcome. But with the empirical research, you could have observational. Most of the work we'll be doing will be based on observational data, so you have no intervention as a researcher. So you want to see what happened to the exchange rate in the UK based on after Brexit, so you just collect data about exchange rate after that period. Okay, as a researcher, you have no intervention. You haven't changed anything in the exchange rate. You didn't have. You've done nothing to the exchange rate. You actually just observing or collecting observational data. So there's no intervention. There is another side of this research or empirical research that you can actually do some experiment, which is actually fun as well. So as a researcher, you will have like two groups. One group, you could have some sort of treatment and you want to evaluate the effect of this treatment on the treated group, and then you compare. So you've done something. So you have like a group that you expose to some sort of intervention, and then you have another group that is not, and then you try to compare between both. And again, this is another area of empirical research. So in all cases, what we're going to be focusing on mainly in this course is empirical research. So we're not going to talk about theoretical research, but theory is always important. As you'll see in this course, later in this lecture and the whole course, everything starts from theory. Okay, so if you have a question that you want to find answer, you need first to start from theory. You need to start first. You must have some theory that explain how the variables involved interact with each other. So the first step to write an empirical paper, you need a question, but then you need to think of the theoretical background. What economic theory tell us? So if you want to have a model, to estimate a model based on which you can come to a conclusion related to how households would react to price change or income change or whatever. So you need first to start from theory. What does economic theory tell us about that? About the behavior of households when income change. So it's always important. I know you expect me to jump to, okay, this is the data, here's how we do, this is what we do, but you still need to think about the why we do that. So the most important part in this course is not just how, is why. Okay? So let's agree from day one, whatever you do in this module, not just think of how to do it, think of also of why you're doing it. Okay? So it's very important. So when you do, even in your coursework, your dissertation, the same way you can apply this to any empirical piece you're working on. So first you start with the research question, then you need to think about how the variables, the main variables involved here interact, how you expect them to interact, or what economic theory or what theory tell us about these variables. Okay, so this is very, very important. Then you need to look at published research, because published research give you an idea about what has been done. Okay, so there is no point if you're going to do exactly something that has been done before, using the same data, using in the same situation, you're just replicating the whole thing, using the same method, so it's not really adding much to our knowledge. So that's why you need to start from where others, what others wrote about this topic. So you need to be familiar with published research. It gives you knowledge about the data and also give you knowledge about empirical techniques. This is one question that I receive nearly every couple of days through these channels, Facebook or Twitter. Like, people contact me from different places, ask me, okay, I'm working on this, what to do? Like, which technique, what method should I use? I say, just go read your literature review. Do your literature review first. You will know what people do, what people use. Okay? So before you ask me, just do some work first. Okay? Do your part first. Okay? Go and see the published research. That will give you an idea about where to get data from. Again, they ask me where to get data from. So sorry, just go and see what others did. Okay? And also you will see the techniques, what sort of techniques they have used. And then you see where econometrics come? It comes last. This is where econometrics come, at the end. Okay? After you've done this. So you've done your part, you have a research question. Remember, there's no point to do research if you don't have a question to answer. So there's a very interesting question, at least to yourself, you find it interesting, you think it is interesting, but also you need to convince others that it is interesting. It's not just because you like it, or it seems funny or nice, so that's why I'm doing it. And here comes the motivation. That's what we call the motivation. That's what we ask people always. Where's your motivation? What is your motivation? Why should I care about your research? Why should I read your work? Okay, so the research question is important to be able to convince others or show others that actually it is something important, it's something interesting, and something that they should care about. Anyway, so the whole point from this introduction is to put econometrics in context. Okay, so don't never do econometrics without thinking about these steps first. Why I'm here? Why am I doing this? I need to think first. What's my research question? What theory tell me about this? So what should I expect? How do these variables interact? Okay, and then what others have done. So read some papers, read some work. And then this will give you ideas about data, the source of data, the techniques, what others have found. And then, okay, I'm going actually to contribute now. I'm going to tell people something they don't know. And that is the contribution. That's why you do this. Okay? So again, it's not, you don't do empirical research because, again, the sake of research, or you want to look. Anyway, so the idea here is just you need to think more in depth about what you're actually doing and why you're doing it. And as I said, the most important message so far is where econometrics lies here. Actually, it comes after all of this. Okay, we focus on econometrics, but from time to time we'll go back to talk about, okay, so what, let's pretend that this is our research question. Okay, let's say, okay, what theory says about that and what should we expect, etc. And as I said, in this module, you'll be expected to read research papers. Okay, so I'll be referring to recent research, my lecture notes, and you're expected to read these papers. A few papers. I'm not going to be asking for too much, okay? But at least last year I put like 5-6 papers for the whole semester for people to read and to comment on. So not just to read, to be critical when you read those papers, okay? Because there's a reason why I put these papers there, not just to read them, also to be able to comment on what methods they have used, whether these methods address the research question or not, and so on. So we try to go beyond how to do econometrics to why you do this, okay? So keep this always in your mind. Anyway, so this is about writing empirical research. This is an example of one of my papers, Catching the Mirage, the Shadow Impact of Financial Crisis. Came out 2017, the Quarter Review of Economics and Finance. So our research question this paper, we ask the question, how do shadow economy, when we talk about the shadow economy, we talk about the undergrad economy or the economic activities that off the record. So it could be anything, could be legal activities or illegal activities. So drug dealing is part of the shadow economy. Again, there's no records, okay? So what we try to say, okay, how does this part of the economy, how does this sector of the economy behave in time of crisis? If we have a financial shock, financial crisis, that's what we were interested in. How does the shadow economy react? Does it expand? So that means more people or people who lose their jobs in the formal sector, they go to work informal or go to work in the shadow economy. So that means the shadow economy, the size of the shadow economy increases. Or the shock affect both the formal economy or the official GDP and the shadow economy as well. So that means it can go either way. So because this is what economic theory tells us. So substitution effect means that those who lose jobs here, they will go and join the shadow economy. In that case, the shadow economy absorbed the shock or help the economy to absorb the shock or mitigate the effect or the negative impact of the shock, because those who lose their jobs in the formal economy, they actually, in the formal sector, they go actually and find some jobs, not necessarily 100% of those who lose jobs, but at least it helps. On the other side, income effect means like actually both sides of the economy are affected badly by the shock, and it's not going to help, actually it will shrink or it will decrease in size. So that was the research question, and that was our expectation. So, or the theoretical expectation of what would we expect in time of crisis. Here comes the challenges, because the shadow economy, we said it's not recorded. So how are we going to measure it? So that's the first challenge, okay? We'll come back to this later when we talk about one of the lectures. But in general, you need to be aware that this is something very, very difficult to do. And that's why I call it catching the mirage. So something like you don't know where it exists actually. It's like, why are you actually measuring? It's something very, researchers try, they do their best to get something, okay? But it's not necessarily, it doesn't necessarily catch the 100% of the these sort of economic activities. But anyway, so just to give you an idea about writing an empirical research or an empirical paper is just like, it's like a journey. You start with a question, you dig a little bit deeper to see what theory tell us about it, and then these sort of issues arise. Measurement, how are we going to measure what is meant to be covered, like to be in the shadow all the time? It's something you're not meant to see anyway. And then let's assume that now we came with a brilliant idea, which you need to convince others that this is a good idea, or a good way of measuring it, which we did in the paper, but we don't believe it's perfect. It's not. We are very clear about that. And that's the point I raised in the beginning, which is, do you remember? Oh, by the way, you can stop me and you can talk to me in the lecture. Okay? So do you remember? Yes, but this is not just the point. The point is you need to be aware of the limitations of your work. So we are aware that this is not a perfect measure of the shadow economy. We say it in the paper. We're clear about it. Okay? But we claim that it's the best we could do. We tried. That's the best we can do. Okay? But in the same time, I say from the title of the paper, it's something very difficult to find. It's not like you don't know where it is. Like you can't really. Do you think when you go to a drug dealer and you're never going to ask for a receipt? Probably will shoot you before you do that. Okay? So my point is okay, just be aware. So you don't have to hide the limitation. Okay? You don't need to bury them. You actually need to show that you're aware of the problems in your estimation. Okay? So whatever model you build, whatever estimation you have, just be explicit. Don't be scared to say, okay, yes, I know there are problems here, and these are the problems. Okay? So that's the idea. So I said, well, the measurement is a very challenging task. And we never claim that no one did, not just us. No one did, that they actually find a perfect measure of the shadow economy, something that you're not supposed to see or measure. Okay? But anyway, and then it comes econometrics here. You see, we start talking about econometrics after all these steps, so in that journey. So we were not concerned really about what method to use yet, or what technique to follow yet. We are more concerned about the story of that paper. So where's the question? What do you want to answer? Why is it important to answer that question? And that's exactly what we call the policy implication. Why is it important to know whether the shadow economy expand in size or shrink in times of crisis? Well, because it's a crisis time. Okay? If it does expand and it help or give some chance for the economy to absorb the shock, and that's exactly what we said in the paper, and that's what we found in the paper, by the way. Okay? So maybe some sort of lax enforcement of anti-shadow regulation during bad times might be a good idea. Okay? Let people find jobs even in the shadow or even in the informal sector. Well, okay. Anyway, I'm not trying to sell my paper. I'm not trying to say, okay, I'm saying this is what we said in the paper, okay? So it's a story, it's like a journey you need to go through. And this is how you need to think about your own work. This is how you need to think about your coursework, by the way. Okay? We'll come back to talk about the coursework in a minute. Okay, so that's the story of or the introduction that I wanted to give first, and I want to make sure that everyone gets the idea. We're not just worried about how to do econometrics. It's something that you need to demonstrate you're able to do econometrics anyway, but then we need to just a step further beyond that and think about why. Okay, so the interesting stuff. Okay, what you here for, what you want to hear about. So we will talk about econometrics, or the module. The aims of this module: we aim to introduce different techniques, econometric techniques. You are supposed to get the skill to use real-world data and apply what you learned in class in real-world data, and that's what you will be doing. Okay, in the assignment or in the coursework, you are asked to do that. So you need to deal with real-world data to answer real-world problems. At the end of this, hopefully you will master these sort of techniques. You'll be able to obtain the data, manipulate the data, estimate the model using real world data. The course cover both time series, cross-sectional, and panel data methods. Here's the content. So we'll start with a very basic introduction. And as I said, I know some of you haven't done econometrics or have done econometrics a long time ago, and so we thought, okay, so we can start like just refreshing your memory if you've done it before, or teaching you about it if you haven't done it before. So we start with a very basic model, ordinal least square, OLS, and hypothesis testing. We'll cover some diagnostic tests, and then we'll have part here we talk about time series econometrics, cover unit root, integration, etc. We'll cover also Ash, Gash models, and we'll see how we get on with these techniques. With panel data, we'll cover most of the basic panel data techniques, fixed effect, random effect, but also we'll try to do some more advanced stuff about dynamic panel data models. Simultaneous equation systems, we'll cover identification, estimation, and we will finish by some work on limited dependent variables models and instrumental variables. So don't worry about this, whether you know some of this or you don't know any of this, or you've got, or you know all of it, so it's fine. So just don't worry about the content for now. Okay. In general, I encourage people to bring their laptops, not just in the lecture, because we have the tutorial or the computer lab after the lecture. I'm not going to fill the 2 hours, so I give you some break before the seminar, before the computer lab session. But why I want you to bring your laptops or your devices? Because I want you to install the program that we will be using on your computers. From time to time also, I'll be using an online platform called Socrative, which I'll post some questions. You will log in using your devices. You just answer those questions if you wish, and I encourage everyone to do that. But in general, it's a good idea. Well, we will go to a lab for the computer lab, but your work will be in that computer. But it would be nice if you can install the program in your laptop, have your all your work in your own device, in your own computer. You'll see if there is any issue, error message, how to deal with that, all these sort of issues. It's good to have it in one place in your computer. But anyway, I usually use Socrative to post questions, and you can answer these questions online. Okay, if you don't want to bring your laptop, that's fine. If you have a tablet, if you have a mobile phone, it's fine, as long as it's connected to the internet. But that's okay for Socrative. But if you want R, if you want really to put the statistical software and to do the work, you probably need a laptop or a computer. But if you don't want, that's fine. We're going to a computer lab, so you can use the computer lab. So it's not a big deal really. But it's just it's my preference. If I was studying R or a new software, I would love to bring my laptop and do everything on my laptop, in case if there are any issues or any problems with the software, so I can actually deal with it, okay, on the laptop. Anyway, so as I said before, like everything will be, all the material will be in Blackboard. This is our virtual learning environment for this year. It will change next year. Hanomics, the YouTube channel, hopefully, recording this now, hopefully there will be no technical issues, and I'll post the videos on YouTube, on Hanomics YouTube channel. Okay, that's the exciting part. This is R. Okay, has anyone worked with R before? Anyone know what R is? You know what R is? That's great. That's a very good start. Okay, so R is just a statistical software. It's an open source software, and that's why I choose it, because you don't need to pay for it. You can just download it for free, and it does amazing job. Okay, so it replaces eViews, Stata, all whatever you might have used in the past in your undergrad degree. So it's an open source, it's free, so you can have it in your laptop. Okay, you don't need to buy it, and it also works in Windows, Mac, whatever. You can even work on the web if you want, okay, on the server. And it also has incredible learning resources and support. Don't worry, I'm not assuming you have any idea about R. Okay, so I didn't make any assumption when I introduced R in this module. Okay, so we'll work together, we'll do it together, and I hope you will enjoy it. It's a very interesting and nice software. So as I said, I assume you are beginners. No one has heard about R before. Just to let you know, so the main program is R, but it looks a bit ugly. So that's why you need to have Rstudio as well. Okay, you don't have to, but it would be nice to. I work through Rstudio, but you need to install this first and then Rstudio. So Rstudio is just an interface, so something to see, but in the background it's actually R. It's a programming language, so it's different skill from what you have. You might have had in your undergrad, where you have some menus and eViews. You click some menus, you give the results, you interpret the results. Here you need to write your code, so you will learn some programming skills, which really good for your employability if you want to find a job after. I mean, I'm sure everyone wants to, but I'm just saying, when you look for a job, it's really nice to say in your CV, I can work with R. I have programming skills. Okay, so don't be scared. It's a journey we'll take together, and I would be happy to offer as support as much as I can. So with every step, okay. And during my office hours, please, bring your laptop. Come and sit with me in the office. Bring your data, okay? Tell me something you don't know how to do it. We'll do it together, okay? So let's do this. We'll see how we get on with it. But anyway, just as a start, as I said, these are two different applications or software. You need to install R first, and then you install Rstudio because it works with R. It's just user-friendly, and it's easier to program through Rstudio. To install R in your computer, here's the. If you click on that in the lecture in the notes, it will take you to the website. So whenever you see click here, generally it says there's like a web link. Okay, this is install Rstudio. To install Rstudio, and if you want to learn more about installing these two softwares, it's very straightforward. You just choose whatever computer you have. If you have Windows-based computer, Mac, or whatever you have, just choose whatever relevant to your computer, and then here like a really large set of tutorials about learning R. Okay, just play with it. We'll do stuff in the tutorial, in the computer lab, okay? But I'm just saying, LAR is just very open. It's like the whole world is yours. Just do and learn as much as you want. No one will stop you, okay? There's plenty of resources there, and this is just an example. There's only one web page with hundreds of examples just on how to do anything in R or many things in R. Okay, yeah, this is the full set of R tutorials, and also I hope I will record a few videos and post them as well. So we'll go through it step by step. There's no rush, but at least if you're curious and you want to really to move faster with R, here you go. So these are some examples of resources that you can find about R. Okay, now comes the computer labs. The computer labs, I thought, okay, if we sit in a computer lab, going through R, you'll see some people with like having some error messages. Some people are going faster, some people are going slower, and it's not going like not everyone is going to go in the same pace at the same pace. So I thought, well, it's actually better if I record the session, whatever I want to cover in a session, in a 5-minute video or 10-minute video maximum. It's not going to be more than that, probably 5 minutes. Okay, you watch it before the tutorial, and you come in the computer lab. We do some similar questions or tasks. So you practice it before you come. Okay, you've done it before you come. So you come into the tutorial to do more. Okay, so the question is, what if? So okay, can we apply this in a different data set? That's what I'm going to do in a tutorial. Okay, in a tutorial session. I'll give you a different data set. Okay, can you do the same? Okay, how about if you want to do something more, which I didn't cover in the video, where to find it? Okay, so the video will be like very basic example, which I hope you all will practice before you come. And then when you come to the tutorial, then we'll do more stuff, and then I'll be moving around to help people with error messages where people have questions about, okay, I want actually to do more, how can I do that? Or I've got an idea how to do it, okay, in R. So it would be, so that's what we call flipped classroom. So you're actually going to do the task before you come to the classroom. Okay, is that clear? Okay, okay. Okay, assessment. Assessment, there's 5 in-class tests, okay? So, and this will take place during the tutorial labs. So you need to attend lectures and computer labs, okay? So the test will be at the end of the session. So we'll probably start the session, and then we'll leave maybe 15 minutes for the test. The test will be in the computer. There'll be some tasks to do on your computer using the program, and it will cover something we covered the previous week. So I'm not going to test you or assess you based on what we covered in the present or in the current tutorial session. You actually had a week, or you will have a week to cover what we cover, and then I'll be asking you 1 or 2 questions. It's not going to be a very long or very demanding task at all, okay? And then all what you need to do is just to enter your answer, do the task first in the program, or answer the question, and do that on the computer, okay? We'll do it in the lab. You don't need to bring your laptop, but it will be good if you have your laptop to work on, but it's fine. I mean, it's not a big deal really if you think it's difficult to bring your laptop. So that's going to be 25% of the mark. The other 25% will be individual coursework, okay? And in the individual coursework, it's very open. There's no question. The question is to use R. So this is a must. So I don't want people to say, okay, I can do this, but I can do it in views. No, you will do it in R, okay? And that's why we're learning R. Or I can do this in Stata. Or can I do it in a different software? No, we'll do it in R, okay? I had this last year, so I just want to make it clear now. Okay, so you will use oil price data, and I'll show you where to find oil price data. And there's nothing in R. There's different ways to obtain data using R. Okay, it's something you will enjoy. And apply one of the time series techniques that we will cover in this module to answer a question. It's your own question. So you first need to identify that question. Okay, it could be linking or studying the effect of oil prices on whatever exchange rate, GDP, whatever. Like it's going. That means you need to read some research. Okay, in order to identify that research question, you need to really read some work about oil price, and in the lecture we'll be referring to this work anyway. So you will have some examples of research that is done on oil prices and other variables. Anyway, I'll finish in a few minutes. I'll give you a break. If you wish to have a break, of course. If you don't want, that's fine. We can carry on. So that's the assignment. More details about the assignment in the module handbook and on Blackboard. Okay, there's a different file for the assignment. So all the same. It's the same question, but with more instructions how to do what is expected from you. Okay, so this is 25% of the mark, and the report is short report. It's 2,000 words. Okay, but believe me, if you write 1,000 words properly, like you have really like good quality, you might get more than you get higher mark than somebody who just wrote 2,000 words for the sake of hitting the 2,000 maximum. No, it's not me. Those who know me in the past, I told them in the past, they know I never count how many words you write, unless I feel it's boring. So you'll be in trouble if I start counting the words. Okay, so I don't count the words. I care more about the quality of your work. So 1,000, 2,000, 2,000 is the maximum. 1,500, I don't really care how much you wrote. I care more about the quality of what I'm reading. Okay, and with this one, you will have to submit not just the report. You will have to submit the data you used and the script, the R code, the program you wrote. Again, don't worry, we'll learn how to write a program. This is not a problem. Okay, but you will need to submit it so I can if I run the code, I should be able to get the same results. Okay, reproduce exactly the same result. The exam, so that's 25%. The exam is 50%, and you have 2 questions. Section A, you'll answer all questions in section A. Section B, you've got choice, 1 out of 4 questions. And don't worry, the questions usually come from the research papers I gave to you. So you need to read them, okay? So you need to read them, okay? So just read the papers I post on Blackboard or the papers I refer to. Because what I do is very simple. I give you a snapshot of the results and say, comment on the results, tell me what this result means. I give you like a table or a graph, say, what does that mean? And I give you a short description about the research question or what the researcher was trying to do, and then I ask you 2 things. So from now, you see, from lecture 1, you know the exam. You see? It's very easy. So there are 2 questions I ask. Explain these results and assess the work. Tell me. You need to be critically remember why they were doing that and what are the limitations. That's it. Okay? So it's very, very straightforward. So shouldn't be a problem. Anyway, so that's the assessment. Would you like to have a break? Yeah. Okay. Okay, let's have 10-minute break. We'll come back. We'll give some example, and then we'll go after. Okay? Thank you so much. So what I was saying, so I'm not going to take long in this part of the session. Just I'm going to show you some example in R, and then we'll have a longer break, hopefully, and then we'll head to the computer lab in the School of Management building. It's the first floor, room 128, if I remember. Anyway, so I was just talking about the assessment. 25% in class tests, 5 in-class tests. So it's 5 marks each, 5% each. 25% individual coursework, so you'll do your research on oil prices, okay? Use your real-world data, you identify a research question, follow the research, the literature on oil prices, and use R, and you will submit your data and your program along with your written report. Okay, the report, 2,000 words. You don't need to hit the 2,000 word. The quality comes before the quantity. So please don't worry about the maximum as long as you didn't exceed that maximum, because that is not good. Final exam, 50%. Okay, so let's now, the deadline for the coursework is 22nd of November. So it's not a long time to go. Time will fly, you'll see. Okay, so the books, the textbook we will use, there are books that use econometrics with R, which they all available online. So you don't need to go to the library to download them. So the 3 books are there. So just click on the link. It will take you to the website. Okay, so these 3 books using econometrics with R, as I said, it's incredible support there. It's amazing community, and you will love it. Okay, so anything, any question, any problem you have, there must be someone online. Put it there and put the answer, and just make your life really nice. Okay, so you see like amazing people using R. People write very complicated like codes, and they just make it available to everyone to use. Just very, very amazing group. Anyway, there's also a few other books if you want to read more about econometrics, not just R. Okay, the office hours. So it's Monday and Tuesday, 10:30 to 11:30. And as I said, please, and I always say that, and I really want you to make the most of my office hours. Okay, bring your laptop. You're having problems with R, or you're estimating something and it seems not working, or you're having issues, or you want to do something but you don't know how to do it. Okay, that's why we have office hours. Okay, so bring your laptop, bring your data, and come and let's have a chat about it. Okay, let's do it together. So I'll be happy to help as much as I can. Okay, so please come in during my office hours, and if you come by my office outside these hours and you see the door open, just come and say hello. Just come and ask me. If I'm super busy and I can't help, I'll tell you when to come back. Okay, but usually I should be able to help if it's something that I can do very quickly, so I wouldn't mind. So please, even if you around outside the office hours and you want to come to the office, I don't promise I'll be there, but if I am there, then please come and talk to me. Okay, so my office is 208, the second floor in the School of Management building. Okay, so now let's put things into context now. So now, regression model. That's what we do in econometrics. We try to build a model. And to build a model, we have what we call the population that we want to study. And there is something we want to explain, which we call the dependent variable. That's the variable we want to explain its behavior. Okay, could be the quantity demand, could be consumption, could be whatever. Okay, and that variable, we think, or from theory we know, that it depends on other factors, and these factors on the right-hand side, these x's there, the independent variables. So for the dependent variable, you can call it explained or regressant or outcome variable. So these all are the same. The x's are the independent variables, explanatory, regressors, predictors, or covariates, call it whatever you want. So they're all the same. Okay? And because you can't include all the explanatory variables, all the factors that explain the behavior of y, that's why we need some error, okay, which is the error term. So because we can't include everything here, so we still have some component that we don't know much about. And because of that, we need to make some assumptions about the behavior of this error. Okay? And because it's an error, that means there should be no important factor that affects y included in this error. So meaning that these x's should be the most important factors that explain the behavior of y. The subscript here just denote the observation, the ith observation. So in cross-sectional data, we used to, it's like some kind of conventional way of using the subscript. So we use I. If it is time series data, we use T. And if you don't know the difference, so when we talk about cross-sectional data, we collect data about different units. These units could be us, individuals, at one point in time. Okay? So if I collect data about everyone in this room, now, how much money you've got in your pocket, like your income, okay? This is cross-sectional data. Because I came at this point in time, and I collect this data about many objects, many subjects, which are individual in this case, but could be countries. You could collect data about GDP today, collect data about 100 countries or whatever, like 10 countries or 20 countries. So, but it is at one point in time. So in that case, this is a cross-section data. But if I collect data for one subject, okay, one unit, this unit could be individual, could be country, could be firm, name it, it's fine. Over time, that's time series data. So cross-section, you have different unit at one point in time. So there's no change in time. It's only one point in time. That's cross-section. Time series, you have one unit, not a number of units, one unit over time. When you have both, you got panel data. Okay? So these are the three types of data we'll be working with. But we'll come back to this point later. So our task here is, so the data we collect is about y, is the variable we want to explain. X1 is the variable or the factor that we think affect y, we know from theory, and the other x's are the same. And this error will capture everything else that's not included in this equation. Okay? So when I talk about a model, I mean the equation, this equation. Okay? So we're starting with a single equation model where we have only one equation. Okay? When you move further in this module, will come across some models that actually more than a single equation model, but this is the simplest model, is when you have one equation model, single equation model. Okay? So we're starting, this is a starting point. You can write this in a compact way like this. Okay, so this is like a matrix notation where x here contain all these x's, and this beta contain all these betas. Okay, but the question here, what are betas? What are these betas? This is actually what we want to estimate. This is what we want to use econometrics to estimate some values for. So these x here, we have data, so we observe this. We have data for x's. We have data for y. We don't know much about the error term. We'll make some assumptions. We'll test those assumptions. We need to make sure they are valid. And then our task actually is to estimate the beta, to get values for this beta. Because these betas, we call them the partial effect, which means this is when x change by 1 unit, for example, y should change by how much beta is. Okay? So that's why we want to know the value of that beta. But how can we know that? How can we do that? This is the population, meaning that everyone, let's say, in Swansea University, or everyone in the UK, if you want to talk about how, for example, income affect household consumption. So we actually need to collect data about all households in the UK. That's the population, okay? But sometimes it's not possible. It's not an easy task to do that. It's very costly, and sometimes it's not even possible to do that. So that's why we rely on a sample, okay? So that's why we collect data from a sample. So I just put these small letters here to just show the difference between the population equation. This is for the whole population. So this is the true values of the parameters are betas. This is what I want to estimate. But our estimation from that based on a sample, I call it B small. See the difference? The other one, big beta. This is like small b. So whatever we're doing here, as I said, our task is to predict, or sorry, is to estimate these betas. And this line here show you the one of the main messages of this lecture, that causal relationship should be based on theory. Why should I believe the relationship here goes from X to Y? Why should I believe X affect Y? Why should I believe income affect consumption? Why should I believe that? Why should I believe that income affect consumption? Why should I think there is a causal relationship between income and consumption? It comes from theory. That's what economic theory tell me, okay? I'll give you a very naive example, okay? So if you, whatever software you have, if you have data about rainfall, the amount of rainfall, and the amount of crops in the field, okay? And you want to build an econometric model using this data. Which one will be the dependent variable? Yeah? Yeah, the amount of crops. Crops will be the dependent variable. The independent variable will be, because you think the rainfall causes, okay, so the relationship goes from rainfall to, so X is rainfall, Y is the crops, okay? That's very good, because this is the common sense, that's the intuition, or the theory. So that causality, that causal relationship, doesn't come from the regression, doesn't come from that equation, okay? In your software, if you put it the other way around, you know what's gonna happen? The software is stupid. It will give you results. It's not going to tell you, hold on, you're doing something stupid, because he's stupid too, okay? So it's not going to stop you, okay? So my point here, any causal relationship, when you say X affects Y or X influence Y, you need to think about theory or about common sense in that case when we talk about rainfall and crops, okay? So I can't say, okay, I'm going to say, well, if we have more crops, that means we will receive more rainfall, like more rain will come. That's stupid, isn't it? Doesn't make sense, okay? So it doesn't work that way. So as I said, so you always need to think about theory, okay? You need to get this from theory. What X's to put there? So look, theory, literature, etc. This is the introduction we gave in the beginning, okay? Anyway, so that's great. Okay, so that was very important, as I said. And the error term, U, it's an error, okay? And this capture everything else that is not included. So any X that is not included in this model, its effect goes to, or is captured by the error term. And because this is an error, we want it to be as small as possible. We don't want to have, inside that error, we don't want to have important variables or important factors that affect Y. And as I said, we can't use the population for many reasons, many considerations, and that's why we collect samples. So when we collect sample, this is exactly the same equation. So B here, the small b here, is just the estimation of beta, okay, of the true parameter from the population. And it has two components, what we call the deterministic component, which doesn't include the residuals or the error term. In this case, we call it the residual with the sample. Okay, so it doesn't include this part, so this is called the deterministic component plus the residuals. So how are we going to do the estimation? The simplest way to do it is the OLS, the ordinary least square. It's the statistical method by which we try to minimize the error sum of square. Okay, note that this is not the sum of the error term, actually this squared, because the error term you always have like positive and negative values, so if you add them together, they will cancel each other. That's why we get the sum of the squared, of their term squared. Okay, so if you good in math, you can actually prove that, or you can actually obtain values for beta 0 and beta 1. All what you need to do is to get the first derivative and make it equal 0. So what we're trying to do here is to minimize, to get these values of beta 0 and beta 1 that minimizes this. Why do you want to minimize it? Why do you want it? Why do we want to minimize it? Yeah. Yes, because that's an error. Okay, we want to have important stuff in the model. So what is in the error is the rest. So we don't want the rest that to be important. We want that to be small. Okay, so we want that values, the betas, the values of those betas, or the estimation of those betas, to actually minimize this. So we want to find these betas that minimize this. So the idea here is, again, you can prove it, or you can do it mathematically by obtaining the first derivative and make it equal to 0, and then you get, this will give you an equation for beta 0 and beta 1, and that's exactly what the software does. Okay, there's one thing left, which is which I said earlier, is about the error term. Okay, the error term, we don't know it, we don't see it, so we need to make some assumptions about how it behaves. Okay, so we want it to be a good error, like something we like. Okay, and these are the assumptions are the linear model assume, or the model that we've seen here, which we call the linear model, and I'll explain why. First of all, it's linear in parameters, meaning that's why it's called linear. When you look at these betas, okay, so all these betas are raised to the power of 1. So there's no beta square or beta. So it's only the betas. So that's why it's linear. So it's linear in parameters. That means on these betas, you don't see non-linear betas. It's all linear. The second assumption is the regressors are fixed, non-stochastic. So we collect data about income. So at certain levels of income, we collect data about for different households, how much they consume. So we have two variables, income and consumption. In that case, regressors are non-stochastic. The expected value of the error term is 0. So on average, we expect that error given x to be 0. It's an error. We want it to be 0. So on average, so as I said, positive values with negative values, they should cancel each other, and then we end, on average, we have 0. So the expected value of, and again, we don't see the error term, we don't know it. We're making assumptions about it. And whenever you make assumptions, you need to test whether these assumptions are valid, and this is what we call the diagnostic test, which we'll cover next lecture. Okay? So far, we're just making assumptions today. Next time when we come next week, when we meet, we'll talk about, okay, how can I make sure that these assumptions are true? Okay, so we may just make assumptions about the error term, stochastic term, or constant error variance of errors. That means the variance of the error term is constant. It's sigma square. Sigma square is just a notation to denote the variance. No autocorrelation, that means the errors are not correlated, so between different subjects or over time, so UI and UJ are not correlated, meaning that the covariance between both are 0. No multicollinearity. That means no perfect correlation between these x's. Okay, and as I said, we'll come back to these to talk about this in more detail next lecture, because we need to test for these assumptions. And the last one, the no specification bias. So we'll come back to these assumptions, we'll test these assumptions, we'll show how to deal with these assumptions if they are not valid. But so far, these are the assumptions. The good error we would love to see there, these are the assumptions. And if everything is good, that means we have blue estimator. That's what we love in econometrics. Blue, we have the best, B stands for the best, L stands for linear, U stands for unbiased, E stands for estimator. So blue, best, linear, unbiased estimator. Wow, we get something sounds good. Okay, so if those assumptions are valid, and that's the problem. Okay, in many cases, they're not. Okay, so you test for them and then you do some corrections or how to deal with that. So, as I said, linear, it's a linear function of the dependent variable, the estimators betas. The estimators are unbiased, mean that when you, if you estimate B, which is the estimator of beta, the big one, if you draw a sample and you estimate, use that O less, the nice thing to minimize the square of the error, sum square of the error, then you will get a number, like a value for that B. If you draw another sample, you'll get a different value for, and then if you repeat that many times, on average, that means in repeated samples, so your estimator on average, so if you get the average of all these values, it should be very close to the beta, the true value from the population. Okay. The last one, which is the word, the letter B, which is the best, meaning the one that has minimum variance. Because, as I said, when you when you draw different samples, you get different values for betas. And then if you get on average, that means you look at the biasness. If that on average very close to the true parameter, that means your estimator is unbiased. And also if you get the variance, and if you have two estimators or three estimators or a number of estimators, and one of them, the one that has the minimum variance, that will be the best, and which we call the efficient estimator, because it's the one with the minimum variance. So if you have a number of estimators to choose from, then you choose which one? The one that has the minimum variance. Anyway, so this is the whole story, okay? So the example we had now, or the regression model we looked at now, is the simplest model. We have a single equation model. We have a dependent variable, one equation. We have a dependent variable, y, and some x's, independent variables on the right-hand side. And because we can't do this in the population, we withdraw sample, and we use O less to estimate betas. Okay? And why we want to estimate the betas? Because I said betas, that's the relationship between x and y. So if x increased by 1 unit, then y will increase by how much? Or it will change by how much, because it could be positive or negative. Yes, by the value of the estimated beta. That's what we estimate, that's what we get. Okay? So when I go back to this, that's the whole job. That's your job. Okay? To give me a value of this, to estimate a value of this beta. And why? Because when this will tell us when x change, how much by 1 unit, how much y will change is by the value estimated for beta. We'll come back to this when we look at an example. Okay, so let's have an example quickly. I'm not going to take more than 5 minutes. Okay? What is the important thing to do when you write an empirical paper? Or what are the steps? We want now to discuss an example of a regression model. Should we jump to all this? No. You need to think of first, what's your research question? Is that right? You see, I'm repeating the same slide. It's there, nothing new. So what's the research question? Okay? And then what does economic theory tell us about these variables? And then what happened in the literature? And then we'll do econometrics. Okay? So I just put it there for you to remember, or to remind you that econometrics is not for sake. You actually need to think about why we do that. But anyway, so let's now, as I said, theory comes first. If you want to study what determines earnings or wages, okay, you need to think about what theory tell us. Why an employer will pay X or person A more than person B, or why a male or a female could earn less than a male. So like there are different things to think about. So in terms of theory, there's plenty of things to actually consider when you talk about wage and economic theory. You might think about marginal productivity theory, and you say, okay, in a perfect competition condition, equilibrium in labor market will happen when labor supply equal the demand for labor. And you can say, okay, employer usually pay more wages when, for those who are like they are more productive, and they pay the wages that happen, that this is the marginal productivity of that labor times the price of the product, and that's exactly how much they pay them. So they don't pay them more or less than that. This is the kind of equilibrium. So I don't want to bother you with the details if you're not coming from economics background, but my point here is that there's theory involved. So it's not just the econometrics. Okay, so, and why the people earn differently? Let's say why people who have the same, two persons who have the same education, the same background, very similar background, why do they earn differently? Again, there's some explanation. It could be related to human capital, education. It could be related to geographical area. It could be related to job characteristics. So there's so many factors involved here. So so this is the kind of the theory involved, like different things that you need to consider. And then I didn't write anything about the literature, but you still you can. It's for you. You can, if you're interested to learn more about wage determinants, you can actually look into the literature. See, there's a large body of literature about this wage determinants. In the example we have, which we will work on this example next week in the tutorial and the computer lab, we use data, cross-sectional data. What do we mean by cross-sectional data? We collect data about different people at the same point in time. So there's no time there, just this single point in time. Okay, we have large or many units. Units here means people or households. And this data come from this paper, and I think I cited this paper at the end. And they have a random sample collected 1985, and this is the model we want to estimate. Okay, so what is the variable we want to explain its behavior? It's wage. Okay, and according to what we covered, what we talk about theory, it seems that education sounds important determinant of wage. Okay, so the wage you receive depend on the education. Okay, and also it depends on your experience. Okay, so let's assume that this is what theory tells us, only these two variables, or at least we believe that these are the most important variables. Then there are other things that are not included. Where they go? To the error. Okay, so they live inside that error. Okay, so anything that is not there and affect wage, it's in the error. So we will see this next next time when we have the computer lab. So you will see how you can actually import the data into R very easily, following some commands. You will see today in the lab how to install different packages, okay? And we learn more about what we mean by packages. It's just different commands, okay? Or a collection of commands, because package is something bigger than just a function. So function is just a command, and then you have something that contain these like a large number, like many of them, so in a package. And then we learn how to install it. And then we learn how to produce tables like this. This is like a snapshot of the data that we will work on next time. You will see data. These are the first 5 individuals. So we have data about wage, how many years of education they have, how many years experience. We have also data about their age, ethnicity, religion, gender, etc. Okay? So this is just a snapshot of the data. And as I said, this is what you're going to be working on during next computer lab next week. The first thing you should do is descriptive statistics. Okay? What you see up there, this is the command, by the way. What you see down here is the output. Okay? So when you write this, this is what we're going to explain in the computer lab. So don't be scared. Okay? So one line there produces exactly what you see here. Okay? So that line there, it just produces that. So we have 534 observations. So we'll learn today how to import data in the computer lab today. And you could do some interesting stuff like plotting graphs, and we'll see this in as I said in the computer lab. And this is the estimation. Okay. So when I estimated this, so do you remember our job? I'll finish with this, I promise. Do you remember our job, our task with Econometrics? We want to estimate betas. Okay. And these are the estimation of these betas. Do you remember our model? I know I just talked a lot in between. Let me just go back to the model. That's the model. So we have beta 0 is a constant, or beta naught, and beta 1, beta 2. Okay? So we want these estimations. These are the estimations. Okay? So we'll talk about this next time when we do it in the lab, and then we'll talk about the interpretation again next time. Okay? Any questions? Any questions?